very little, actually, compared to other organs in our body. We're beginning to understand some of the fundamental principles about how neurons, that's those little cells in the brain, how they interact with one another. But what we don't know is the fundamental reasons about the connectivity of these neurons. So a human being's got about 85 million neurons in its brain, and the volume of the brain's about, well, I suppose if you put 2 pints of beer on a bar, that would be about the volume of the normal brain. So inside that's about 85 million neurons. Now, the problem, of course, is that now we have these connections called synapses, and these synapses make these connections between these 85 million neurons. And there are 10 to the 15, the order about 10 to the 15 synapses. What does that mean? So it means a 1 with 15 noughts on the end of it. It's a very large but finite number. And we're beginning to understand how those neurons interact. But what we don't fully understand is how we have memory, how we can produce what's called executive function. That means do tasks. We certainly don't understand some of the connectivities that exist between the left and the right hemispheres. So there's a huge amount that we don't know. There certainly are some technologies that will provide advantages, certainly in the case of neurodegenerative diseases, and in some cases also those diseases caused by what's called ischemia in the brain, such as stroke. But it's going to be very interesting over the next 20, 30, 40, even 50 years to see what those advances are in terms of understanding what is clearly an incredibly complex organ within the body. There's some interesting experiments going on over in Cardiff and also in the UK and also in the US, where people are geographically distant. So take 2 people, they're geographically distant. One's got what's called an EEG cap, which means to say they can measure the electrical activity in the brain. And the other person, who's, as I said, geographically distant, but is connected via some internet connection, has what's called a transcranial magnetic stimulator, which is basically just a magnet coil stuck to their heads. And it can induce a magnetic field and therefore alter and increase or decrease the activity in certain parts of the brain. So one person is thinking about, say, tapping their finger, and the other person is actually induced to do that. Well, firstly, we're not really sure whether that works for all people. It may just work for these 2 people. But you can understand that tapping your finger is, it's hardly a high risk, is it? But if you place a gun in a person's hand, then there are some real issues that technology and science, as it always has done, has to answer. What would you think if I knew what you were thinking? That's a very, very hard question to answer. And it may very well be that we might get there.